Here we go. Okay, we are not working in C# today, so we are working in Java. Now, today what we're going to do, our first thing we're going to do is we are going to go over canvas.temple.edu. We're going to go to Canvas, and what we're going to do is we are going to look at, as I promised, one of the problems in the homework. Specifically, what we're going to look at is we are going to look at, let's see, one of the problem, I think it was problem 4, is permutation. Okay. Array list exercises, list functions. Okay. And so, yeah, I made this back in 2018. You can tell I was still very insecure because I felt the need to put the doctor title in front of there. Very insecure past me. Okay. So, anyway, 2.4 is permutation. Write a method called isPermutation, which takes in two list objects that contain the same types. Returns true if the lists are permutations of others, and false if not. Two lists are permutations if they contain the same elements, including the same number of duplicates, but don't contain the items in the same order. So for instance, 1, 2, and 4, and 2, 1, and 4 are permutations of each other. Okay. And just going over here for a second, I want to be clear. Okay, settings. Font, general appearance. Here we go. Fura code. I think 28. Apply. Here we go. That's kind of where I want it. Okay. So, to be clear, 1, 2, 2, and 1, 1, 2 are not permutations of each other. Okay. These are the same combination of items, but not permutations. Permutations rely off of having the same number of the same items of the same numbers in the same quantities. Combinations don't really care about that. Okay, there's a difference between them, and you learn that in any kind of statistics class you take. Anyway, let's go ahead and make a my array list HW class. And what I'm going to do is I'm going to create I'm going to create a couple of different functions because there's a bunch of different ways to solve this problem. Public, static. Now, all of them are going to have a generic type. And if you haven't watched that video, make sure to do so. Public static Boolean is permutation. And we're going to start seeing why we bother having this E here in the first place. Okay. Is permutation list A, sorry, let's call it list A. List E, list B. And then we'll quash our errors. First one is we are going to assume that it is a permutation until proven otherwise. That seems easiest. And then we're going to import all these things we need. Import class. Ta-da. So we've now imported these. That's great. Next. There's a couple different ways. I mean, there's a couple different ways we can go about doing this problem. Okay. The first is the one we're actually going to do last, if at all, which is we're going to go time travel to week 11, essentially, or to week 10, and use hash maps. That is the actually like the preferred way of doing it. Um, as you'll see later in the semester, that's how we solve this problem. That is like the canonical way to do this problem, which is you want to use hash maps and hash tables and the like to solve this problem. The reason being this is a counting problem. We're taking a number of arbitrary things and we're counting how often they occur, and we'll learn that we have a data structure called a hash map or a dictionary that is tailor-made for doing counting of arbitrary things that you don't know what you want to count yet. Okay. Um, so that's the last one. First way we're going to examine this is actually kind of just uh physically count um sorry, for basically what we're going to do is the most direct way is for every item in list A, and I was just figuring out how to phrase this, we got to count the number of times it occurs in both lists. If mismatch, return false. What is going on there? So the idea here is that we need to count is that if we're in order for a permutation, every item in list A needs to occur the same number of times in list A that occurs in list B. And we only have to go through list A because we're going to have one check at the very beginning that's going to help with our logic, which is if list A dot size is not equal to list B dot size, return false. Simply put, if they have different sizes, right, it is physically impossible for them to be in permutations of each other. Why? Because they you just cannot match every item up, right? Right? Every item cannot be paired off. 1, 2, 3, 4 versus 1, 2, 3, 2. Right? We can match off the first 1, 2, and 3, but this last two, well, actually, I don't need this 4. This last two doesn't match up um with it doesn't have any partner to match off with, and basically, so we can see that that the number of twos would be have the wrong count. Similarly, with house this check, if I compared these two, this is list A, this is list B, right, we can see 1 occurs once, 2 occurs once, 3 occurs once, and then we'd be done. But we can see that they're not permutations of each other because 1, 2, 3, 4, that's not going to work. So they've got to have the same item. Also, time for my mini rant on this. As I mentioned, there's a lot of things I like about Java. Java is great. There's a lot of things I like about Python. In the words of Bjorn Strusup, or is it Strausup, the creator of C++. Why am I talking into this one when it's not even plugged in? When I'm getting this one. Okay, anyway. In the words of Bjorn Strusup, there are basically two types. I'm paraphrasing here. There are two types of languages. There are languages people complain about and languages that nobody use. So take that as you will, because every language essentially has its own quirks. So the quirk here for Java is that if you want to figure out how big something is, we got 3 different ways to do that. For an array, it's array.length, no parentheses. For a string, that's string.length with parentheses. And finally, for all the stuff that we're going to be doing in class here, for any data structure, we are going to be doing basically, it's called a collection. So collection dot size. Okay. And I guess it makes sense for an array and a string because they are essentially basically they have a physical length. They go from one index to another, built into memory. But one is a method because it calculates it, and another is a property. Okay, that's a bit weird. But then they break it with size because, some arbitrary data structures don't have lengths. They just have an abstract size. But it throws you for a loop. Okay. Whereas in Python, they assume length, they just simply say, yeah, you use the len function to figure out how big something is, even if it's not actually a length per se, which I like. All right. The final way to solve this method, okay, is we can do sorting, or we can attempt to. I'm sure some of you tried it. The idea here is that basically what we can do is that if we have two different things that are permutations of each other, 1, 4, 1, 5, over here we have and here we have 5, 1, 1, 4. If we sort these two things, right, they end up being the same. 1, 1, 4, 5, and 1, 1, 4, 5. So what we could do is we can offer to figure out whether these things are permutations or not. We can sort them. And if they end up being exactly kind of the same, if the items match off pairwise, that's great. We found a permutation. Perfect. Okay. That does have complications, as we'll see, but we'll find out that that's not too bad. Okay. But it will teach us about this. Now, let's go back to this now. Public static E. Remember, this means that basically that we're enforcing that list A and list B here both are lists of some arbitrary type, but they're the same arbitrary type. So we already know that we don't have to bother checking it to see if, is list A the same type as list B? We know they are. We're enforcing they are. We cannot pass in a list of strings over here and a list of integers over here. This is part of the reason why we use generics. It rules out a whole lot of checks we have to make, right? It means we don't have to do a bunch of type safety checks. We know they're the same type. That's great. So now I'll show you, after all this preamble, why I do this one in class, because doing it this way is messy, and doing it this way leads to a headache. Let's go with messy first. So I'm going to, on purpose, do it this way first with a for each loop on the outside. For each E item in list A, sorry, that was Python. I teach both Python and Java the same semester. So sometimes I accidentally do things like, oh, that's how you would do it in Python. I will fix them. The most annoying thing is that Python does false like this and Java does it like this. So that's the thing I mess up on the most. Anyway, for every item in list A, we need to count the number of times it occurs in list A. And of course, I have to declare what type it is because it's not Python. It's equal to 0. So let's count the number of times this item occurs in list A. For int I is equal to 0. And yes, with IntelliJ, you can just simply type for I, hit tab. Boom. We're good now. Another thing you can do later on is also you can do PSVM for a main and just, public side void main and hit tab. There you go. There's your main function. Part of the reason why I like using IDEs. They've got nice macros like that. Okay. For int I is equal to 0, I is less than list a dot size. Just like doing it for an array, what we're going to do is we are going to say if item dot equals list A dot get I. So we're going to get the item at index. Let's go ahead and make this easier to read, shall we? Right? Especially at this level, we can always optimize later. Nothing hurt, though, by basically saying item A nothing hurt by basically breaking it up to make it easier to read. We're going to get the item at this index, item A. And if that item, if the item we are counting the number of occurrence of is equal to this item, well, we just found it, so we're going to go count A plus plus. Now, this is the reason why I say that this is messy, because look at this. For item in list A, so we're going to iterate over every item in list A, and we're going to then iterate over the list again. So we're iterating over the same list that we're currently iterating over. Wild. Okay. But not only do we do it this way, we also now have to count the number of times it occurs in list B, which is now, if I was using an AI to do this editing, this is some of the things that AI is really good at. I find using AI editors are really useful. A lot of the times, like the code it gives me is trash, but one of the things that AI editors are good at, and I like seeing in this, is that I could basically change this to count B, and it will figure out, oh, not only does count B need to be replaced, but you probably also want to replace item B as well, since this is all about B. It figures out, oh, we had A up there, now it's B, now it's time to go through B, and you don't accidentally miss one like you would as a human. So that's the kind of thing where I find AI to be very useful. That kind of real nasty drudgery. Also, the fact that it would detect that this indentation I did was originally out of bounds, or not out of bounds, but the wrong indentation layer, which is really important in Python. So, so yes, you'll see that and there's a number of us younger faculty who have a very nuanced opinion about AI, about what it's good for and where it hurts students. The kind of stuff where it's going to be just fixing this drudgery for you and helping you make sure you don't make those human mistakes. That's great. That's not the part that's going to be get in the way of learning. Okay. So let's see. Oh, but actually, see, am I in the right for loop? There we go. Now it looks right. Okay. So we've counted the number of times it occurs in list A and the number of times it occurs in list B. Sorry, this is taking so long. Let's go ahead and do count A not equal to count B. If those two things aren't equal, then we found that these are not permutations. Return false. And that is it. As the long and short of this problem. Okay. It's just a mess and longer compared to the other ones. I just, this rubs me the wrong way somehow. Going, this and counting over for each item in A, counting the numbers and times it occurs in list B, that makes sense. Counting for every item in A and then having to loop over it again, it feels wrong some way. All right. Let's go ahead and look about this idea, sorting it. Public, and what we're going to do is we're just going to copy this thing, okay? And because of the way that functions work, it doesn't like having two functions named the same thing. I'm going to call this isPermutation S for sorting, okay? Return false for right now, assuming I can spell false. Apparently I do flaze a lot. Okay. So what we're going to do is we are going to sort list A and list B if only there were sorting functions built into these. List A dot sort. Okay, so this requires something called a comparator, and that's more than I want to do right now. So we go to Google, and basically we would ask, how do we sort a list? Or you go to an AI and ask how you sort a list. And it turns out just like there's an integer class, right, with a bunch of stuff for doing integer stuff, and just how there's an array class for doing a bunch of stuff, arrays, right, that does a bunch of useful stuff for figuring out how to do stuff with arrays, a bunch of utility stuff, including sorting. There is a collections class in javas.util. Automatically imported it, and it takes in a sorting function. And it does the sorting. And look at that. It says, hey, you just need a generic type. It uses T instead of E. I'm sure that's not going to be an issue. And what that does is that it does an in-place sort. It doesn't return anything. It says, given list A, I'm going to sort list A. Well, that's odd. I mean, it's expected on my end, but collections.list A. And if we look at the error here, we get a beautifully, completely deranged explanation that is of no help. Required type, and it might be a bit hard to see on your screen, list T, provided, list E. Reason, no instance of variable type T exists so that E conforms to comparable question mark super T. What in the world? So you might think to yourself, it just wants me to switch it to T instead of E. And that's something they use instead sometimes. I like to use E for element, T for type. But you notice you change it and nothing happens, of course, because in fact it gives you required type, list T, provided type, list T, but in red. Reason, no instance of variable T exists so that T conforms to comparable super. So now we learn why we have this weird notation here. Okay, why we declare a generic type over here. And the reason is that we can be very expressive with what we put in generics. E extends, and this is comparable E. And now it's happy. So there's a lot to explain there, but let's go ahead and finish this code, and then I will explain. Sort list A, sort list B, right? Oh, and before we bother sorting them, of course, let's go ahead and copy this line too. Just make sure that they are this. We could go line by line and basically, yeah, let's go ahead and assume that maybe that, yeah, let's do it this way. Or I, then list A dot size. And we know that list A and list B are going to be the same size. If list A dot get I not equal to list B dot get I turn false, but of course this is Java, so I'm going to use dot equals to compare objects. And if we need to, we can just extract these values to make it a bit saner. In fact, I'll go ahead and do that. And that actually will help me here with explaining this later. So I'm going to use E item, whatever that is, A, E item B equals. And now it's a bit easier to read, in my opinion. There we go. And basically, if we say, hey, these things don't match, then we've got a mismatch somewhere. Okay. Great. So what in the world is going on here? Why didn't this work in the first place? This works just fine, regardless. But the collections.sort, it was giving me this weird error. Now, if we actually read the documentation of collections.sort, which is over here, open in the documentation tool window, it says sorts the item. Actually, yeah, we'll go over here. That's easier to read. Oh, come on. Seriously, you shrink it down? So this is the sort function in the way this works. T comparable, extend, super T. So there's a lot you can do with generics there. But what it's saying over here is that it sorts the specified list in ascending order according to comparable natural ordering of its elements. The sort is guaranteed to be stable, equal, blah, blah, blah. But basically it's saying, hey, these items need to be comparable. Now, what is comparable? Comparable Java. Comparable in Java is an interface, very basic interface. A lot of things use it. Types of objects that need to be compared. Compare, it is an interface that provides only one method, and that's called compare to. Compare to is basically what you use to do arbitrary greater than, less than, except since we're using not necessarily numbers, it may not make sense to use less than. Compare to basically takes in another object of the same type and returns a negative number, a 0, or a positive number. And what this does, it allows you to compare two objects to see what order they occur in. Okay, so let's go ahead and just create a main and play around with it. It's a bit easier to see. This is why live code, it's a bit easier to see it in action rather than not. So I'm going to go ahead and do integer a is equal to, let's go with 5. Integer b is equal to 10. So, and I'm doing integers, that way they're objects, so I can actually call the compare to, because these are comparable. Anything that can be said, hey, I'm going to put this in order, that's a comparable. That's what we're comparing, what order they occur in. So I'm going to go ahead and run this, and we'll see that, no, didn't want to run that one. We'll see that we get -1. Why? Because we get a negative number if A, when we do A dot compared to B, we get a negative number if the first number is smaller than the second. Right, this is a lot smaller. We're still going to get -1. If, on the other hand, let's remove that negative, A is bigger, we're going to get a positive number. And if they're equal, we get a 0. Now you might be wondering, why can't we just use less than or greater than? And Python does that. Python does that just fine because Python decided that was how they wanted to do that. But on the other hand, if we want to compare strings to each other, right, using less than or greater than doesn't necessarily make sense. Yes, you can order strings, but using greater than or less than, at least according to Java's design philosophy, that didn't make sense. So here I'm going to do apple versus banana, okay? And we get -1. But if I do Batman versus banana, interesting things start to occur. We get 6, which is a positive number. And basically it returns kind of the lexicographical distance between these two numbers. Now, you don't need to know that number for sorting. You just need to know positive or negative. But you can encode other information other than just, oh, it's greater than, less than. That's useful. So anyway, long story short, we use the compare to when we want to see what order things come in. Now, compare to is what Java is. So if Java's basically got a program such that if something is comparable, it implements the compare to, which means I can tell what order things are supposed to be in, which means I know it can be sorted. So when we give it just simply E like this, we are basically just telling Java, hey, take any object. But the thing is, not everything is comparable to each other. For instance, let's take a look at scanners, right? You can't necessarily, one scanner versus another, how would you sort a scanner? Intuitively, without any ambiguity, right? Then there's not really one that you can kind of go, oh, that's how you would do it. For strings, it makes sense. It's based off the order it occurs in the dictionary. But for numbers, ascending order, right? But for something like strings, sorry, for scanners, we wouldn't necessarily know. So what we do here is that we can put a limit on the types of things we're getting passed in for isPermutation. Over here, what we're going to say is public static E, and then I wrote extends comparable E. This says I am only going to take in things that are comparable to other E's, right? Weird enforcement of that, but basically it's saying I want to make sure that that I'm only taking in integers that are going to be compared to other integers. I'm only going to take in strings that can be compared to other strings. Make sense? So because of that, we can now sort A and sort list B. On the flip side, you'll remember the first thing I did was check, oh, does list A have a sort function? And the answer is, when we saw, it did have a sort function. It takes in something called a comparator, which is kind of a class you can make on the fly if you needed to. I'm not really going to get into it, but basically, say you did want to sort scanners and you had a very specific idea of how you wanted to do that. You'd implement a comparator so you could compare things, and suddenly now they are comparable. So Java is a very powerful language in that regard. So what to take away from this? Use comparable to sort things. This is more powerful. This doesn't make it, this also means that it doesn't work on everything like this one does, but it's still a useful tool. Okay. And for hash maps and dictionaries, we're going to leave that for week 10. I just wanted to put that on the radar for everybody. Now, what's also interesting is that as we get into week 3, we are going to see that we are going to be comparing runtime efficiencies. And all of these have a different runtime efficiency. Before I forget, though, because you probably want this and you've been, I'm going to just simply drop this code in chat so it is available for you. So I have simply just copy and pasted that, dropped it in the chat so you can have it for your own homework. Okay. Um, and of course the recording is there for you to take it there. Um, Let me just pause for a second. I'm also gonna screen sharing is pause. Good. I'm also just gonna go and drop this on Discord so that it will be available. My Discord, not the modding Discord for RimWorld. That would be silly. So we're gonna go to the 2168 channel, and you can actually, I think you can just, I can code it like that so that we know it's Java code, I believe. Yes, I can. And I love being able to do markdown correctly. Public return true. And then what we need to do is we need to just unindent that. And there we go. And you'll see that you have nice color coordinated code in the Discord channel now. So resume sharing. There we go. So yeah, I just dumped that in Discord as well. Now, as I was saying, we'll find out that each of these options do have a runtime. They have a certain runtime efficiency for figuring out uh, how quickly how quickly these operate. So this we'll find out because we are counting for every item. We're counting it against every item. There are n items, and for every item, we are counting it against 2 other items. That's going to end up being what we call O(n) squared time. quadratic time. Okay. And this is all stuff for week 3. This stuff for here, we're going to learn even later in the semester that this is going to use a sorting algorithm, which will be n times log n. There, LG being the kind of standard for writing log base 2. So a bit more efficient. And then finally, for the third solution, which I did not implement, right, this takes O of n time. So it's the most efficient, but it's going to use up some extra space. All right. So I droned on for quite a bit. Now, since I've been droning on for a while, I want to know, are there any questions that people would like me to answer about the other problems in the homework? Everybody's being so shy today. That is the disadvantage of the lecture. If you don't want to, but if you don't want to, unmute yourself, you can ask your question in the chat, or you can just simply DM me. Okay, the question. So I'm gonna let this populate out. I do see the other questions. I'm gonna let these populate up. These questions populate for a second. Okay, so string to list of word. Okay, I can go over a bit of it. I'm not going to do it in the same level of depth, obviously, because I want you to do these yourself, but I'm definitely going to be able to help. So string to list of word is very different because it asks you to do a couple of different things. Okay. Of course, it would help if I started sharing again. And again, while I'm typing, feel free to dump other things in the chat because again, it can be intimidating saying, "Oh, I need help," to to everybody else in the class. That's why I say go ahead and just DM me using the chat function as opposed to the Discord function. I think I'm just sharing this now. Yes, there we go. Okay. Public static, and now we need. I'm going to just put void here for a second. String to list of words. And what we're going to do here is we're going to do, I'm going to return no, because this wants to return a list of words. What type are the words going to be? Well, words are always strings, so we're going to do list of string as the return type. And string to list of words implies we are taking in a string as our thing, and it's multiple words. So I'm going to call it text. Okay. Now, what we're going to need to do over here is we are going to need to create a array list to hold our answers, right? So the first thing over here is list of string. List is equal to new array list. And that's going to hold a list our answer. And it's going to be our return type. A lot of times for doing these kind of problems, it's super easy to set up. Okay, here's the first thing I'm writing, and that's going to hold that's what our answer is going to be, and I'm going to return the answer. The actual code is now everything else in between. So the main thing where I think students get caught up on this one for this one is that we're taking a string and we're converting it into a list of words. So that means we need to turn a string into something that we can iterate over. Now I mentioned in the footnotes that there is a function, a super helpful function called split, which takes in a regular expression, which again, I would do that extra credit. because because these things are super useful. But I did give you one in the footnotes that said, hey, whoops, if you do / s plus, this splits off of any arbitrary amount of white space. Okay. Meaning that if I give it, and so let's go ahead and just do down here for a test. String A is equal to hello world. This is a test message, right? So what we're going to do now is we are going to do, I'm going to go ahead and turn that into, if I turn this into a bunch of work, sorry, if I do a dot split on this and use that regular expression, and I run this, I'm actually going to get gibberish. You'll see. Why am I getting gibberish? Because it's giving me an array. Annoying, right? So instead what I need is that I need arrays dot toString, which is a useful utility method for taking an array and printing it out. Erroring because the class hasn't been imported. Let's run it. And we'll see that this did just fine. Hello world, this is a test message. Right? So for arrays.toString, the important thing to understand is that this is going to be returning an array of strings. And so the idea here is that we want to get every item in this array into this array list, which we can do just simply by iterating over. And I've basically given you the answer by this point for this one, but the next challenge is and why it's extra credit is you can use this regular expression and learn a bit more about them, and you can write it so that it will get rid of those how to say, it will get rid of those punctuation marks as well and handle punctuation, right? Because as it is, this is the approach you need for figuring out how to do for figuring out how to get it for the regular credit. All right, other questions about any of the other ones? I figure it's easiest to do it like this, and then I can let you, if you need me, you can meet me over Zoom later, but I figured this is the easiest way to handle it, just kind of address it for the class and give us all an early day to prep for that storm.
Actually, Professor, is there any word on if there's going to be cancellations next week because of that?
I haven't even thought about that, but if um you haven't heard, I haven't heard, of course, Temple is going to just simply put Temple, what they typically do is they'll put a banner on top of the front page if there's a cancellation. Unfortunately, like I remember 2 years ago, that when that happened, I was already on my way to school, which was frustrating. And I got to my Japanese class, and my Japanese professor was there to check out the classroom because it was the first day of class, and he kind of looked at me like, class is canceled today. And I'm like, yeah, but I wanted to check out the room and know where it was. And I was already on my way. Oh, it was a late start. That also can happen. That the class does a late start. I'm sorry, or like classes before like 10 are canceled, right? That can happen sometimes. So yeah, play it by ear is what I'll say. Um, Worst case scenario, I can always hold another class via Zoom, right? So all
Gotcha.
right.
Thank you.
Since nobody has other questions to address to their class, this is the way it's going to work. Still got a half an hour left. If you want to leave, you're dismissed. If you have questions for me, stay behind and I'll do my best to answer them. All right. So those of you, as for demos, we'll do that another time. But if you have, but otherwise, if you have like questions to solve things, I'll be happy to stay around to help. So otherwise, bye. All right. If you've got any questions, just feel free to unmute yourself and ask.
Hello. Are
Hi
you
there,
able to?
Michelangelo. How can I
How
help
are
you?
you? I saw that you just did the string to list of words. It says use the equals method in the footnotes there. Is that just a hint for what we could use for the method?
For the equals, I think hold on, let me check the footnote. The equals method is for uniqueness
Oh,
since it's linked to footnote 2, right? You see that?
yeah. Okay.
No worries.
Okay, that makes sense.
Hmm.
Um, and then yeah, think that's all. Uh, and then removal instances, that's one we'll for sure demo in class, right?
Yes, yes, yes.
Okay, perfect. All right, well, uh, thank you.
All right. If that's everything, I get to take an early day.
Have a good one.
Bye.
Bye.